For topic 7, we're going to look at solving a three-part inequality. These are oftentimes called compound inequalities. So at the very beginning of this worksheet, we looked at an example of graphing a compound inequality, which was, let me scroll, which was this example here, example 1, part C. Okay, so a compound inequality has 2 points with like the variable in the middle. That's what it's always going to look like for us. Okay, so that's going to be our end goal. We're going to have, like more stuff going on. We want to simplify it to that point. Luckily, we're not going to do anything super crazy with this. You would do more potentially in a higher level math class, like a Math 171, a pre-calculus algebra, but for us, really basic stuff, okay? The one thing I do want you to understand is when you read an inequality, it has to read true from left to right, okay? And what I mean by that is inequalities read from left to right, smallest to largest. So as you are solving these inequalities, there's a rare situation, I don't want to say it's rare, but for us, it's going to be a rare situation where you may have to do some work to fix your final answer because we need them to always read smallest to largest. Okay, so the left-hand side is always the small side, the right-hand side is always the large side when you're reading these inequalities like what we're going to have here. Okay, so our goal is to isolate the variable in the middle. Okay, so we want to isolate the variable in the middle by performing the same operation on all 3 parts. Okay, so instead of adding or subtracting or multiplying or dividing on both sides of the inequality, now we have to add, subtract, multiply, or divide all 3 parts of the inequality. These are generally going to be very, very easy, typically 2 steps. Okay. Now, again, if you were taking a higher level algebra class, you could do more, but for us, just 2 steps. Okay. So for example 7, it says solve each inequality, graph the solution, and express the answer in interval notation. So at this point, we haven't talked about interval notation with a compound inequality, so I'll show you as we go, but I think interval notation here is actually easier, okay? So we have for part A, negative 11 is less than 2x minus 1 is less than or equal to negative 5. Our goal is to isolate x in the center, in this middle piece. So the first thing I want to do is isolate the 2x. That means minus 1 is a problem. So how in math would we undo minus 1? We would add. So we're going to add 1 to the middle, to the right, and to the left. So we have to add 1 on all 3 parts of this inequality. Okay, and then we simplify all 3 parts. So negative 11 plus 1 is negative 10. 2x minus 1 plus 1, well, the minus 1 plus 1 just becomes 0, and I'm left with 2x in the middle. And then that is going to be less than or equal to negative 5 plus 1. Negative 5 plus 1 is negative 4. Okay? And so we've isolated the variable term, but now we need to isolate the variable itself. So we want to undo the multiplication of 2 and x. So we're going to divide all parts by positive 2. So since we're dividing everything by positive, we don't have to reverse anything. So we're going to divide the middle by 2, the right by 2, and the left by 2, and then simplify those 3 parts. So negative 10 divided by 2 is negative 5, which is less than 2x divided by 2, which is just x, because 2 divided by 2 is 1. And then that's less than or equal to negative 4 divided by 2, which is negative 2. So this is our final inequality. Okay, so that's the solution. Now, if I were to graph this, I would draw a number line. I would indicate where both endpoints are, so negative 5 and 2. And then for negative 5, I cannot include it. So negative 5 is less than x, but I can't include exactly negative 5. And then x is less than or equal to negative 2, so I can include the 2. So I'm going to go rounded bracket on 5, square bracket on 2, and then I'm going to shade in the middle. Okay, and just notice what I was saying earlier about when you have an inequality like this, it has to read from left to right, smallest to largest. Okay, well, negative 5 is less than negative 2. Okay, actually, I forgot my negative here. So negative 5 is less than negative 2, so this one reads correctly, and you can see from our solution, it goes left to right like normal. And then finally, for interval notation, just state both endpoints with a comma in between them. So this is saying our solution can be from negative 5 to negative 2. And then you cannot include the 5, but you can include the 2. So that's it. So I think these are really pretty easy. We're not going to do anything super crazy with these inequalities, okay? The worst thing you're going to see is part C. but I vow on my life I would not put Part C on a test. Part C would be great for a lab, an in-class activity, maybe a homework, but I would not put it on a test. Okay, now Part B, same thing. We have negative 10 is less than or equal to 4x plus 6, which is less than 38. We want to isolate x in the middle. The first thing we have to do is isolate the term that contains the x, so we need to move the plus 6. We move plus 6 with subtraction. So subtract 6 from all three parts, and then simplify. 10 minus 6 is 4. 4x plus 6 minus 6 is just going to be 4x. 6 minus 6 is just 0. 4x plus 0 is just 4x. And then 38 minus 6 is 32. Okay? And now we've got the 4x isolated. We want to isolate the x itself. So we need to undo the multiplication of 4 and x. So we divide all three parts, and then we simplify. 4 divided by 4 is 1. 4x divided by 4 is just 1x because 4 divided by itself is 1. 1 times x is x. And then 32 divided by 4 is 8. So just double check, does this read correctly from left to right? Yes, 1 is less than 8. X is somewhere in the middle. So we can graph this. We draw a number line. We put down both of our boundary points, or our end points, you'll call them typically. And then we have to ask ourselves, can we include 1? We certainly may. We can include 1 because we have the or equals 2 inequality. We cannot include 8 because we have just a strict less than inequality. And then x is something, any of these values in the middle. So anything from -1 to 8 without including exactly 8. And then our interval, again, I think interval notation is easier here. You just state both endpoints, put a comma between them. I was about to put an infinity symbol. And then don't include the 8, so we put a rounded bracket. Include the 1, so we put a square bracket. Okay. Now, very easy in this class. Again, if you change your program of study and end up taking higher level math, you may see more with this. And it's more like solving other types of equations and then getting these as potential solutions. Okay. Now for part C, we have 16 is less than -2x plus 4, which is less than or equal to 20. So same thing, we want to isolate the x in the center. So the first step is to isolate the term that contains the x, which is -2x. So we have this plus 4 that's a problem. So we need to move the plus 4 from the center. So we subtract it from all three parts. 16 minus 4 is 12. -2x plus 4 minus 4. Well, plus 4 minus 4 is just 0, so I'm left with just 2x. And then that's less than or equal to 20 minus 4. So 20 minus 4 is 16. Now be careful, this one's a little tricky. We need to undo the multiplication of -2 and x. So we do divide everything by -2. And let's just kind of see what happens when we divide by -2. We go from positive 12 to -6. We go from -2x to positive x, and we go from positive 16 to -8. Okay? Now, can we put our regular inequality symbols in there? And the answer is no. And we know this to be true because we divided everything by a negative, and we know the rules. If we multiply or divide an entire inequality by a negative, we have to reverse the direction of the inequality symbols. But you can see it right here. This one doesn't read correctly. -6 is not less than -8. So you have to be really careful here. And you have to reverse the direction of your inequality symbols. But with inequalities, they read like an inequality like this should read from left to right, smallest to largest. So we have to just do like a mirror image of everything. So we want to write the -8 first, the x still in the middle, the -6 last. And then wherever the point is pointing on the inequality right here, make sure it points to the same thing down here. So for this one right here, we want the point towards the x. For this one right here, we want the point towards the 8. So it should read -8 is less than or equal to x, which is less than -6. This is tricky. I promise you, I would not put something like this on a test. This is a good, like, in-class lab question or a homework question. Okay. So this would be your final answer. It reads correctly now. Okay. -8 really is less than 6, and X is somewhere in the middle. Okay. Now, as far as a graph goes, we indicate our two endpoints. We can include the 8. We cannot include the 6. And then all values for X are somewhere in the middle. Okay. And then our interval is, whoops, got ahead of myself. Our interval is -8 to -6. We cannot include the 6 or the -6, so we put a rounded bracket. We can include the 8, so we put a square bracket. Okay, so something like this is tricky just because we have to reverse the direction of our inequality symbols, and then we have to kind of just like reverse the whole thing. And that can be a little weird. Again, I wouldn't make it a test question, a lab question, potentially a homework question, potentially. Okay. So that's almost it. We have one last application problem. Well, not one last. We have one last example that has two parts. We'll do that in a second or a separate video.